ultimately, the reason we want to determine the empirical formula of a compound is we want to know what the correct molecular formula is. Now, so once you've determined the empirical formula, you're halfway to determining the correct molecular formula, because correct molecular formula is just a multiple of the empirical formula. So for example, if a compound has an empirical formula of CH2, the possible molecular formulas would be CH2, or, so that's a ratio of 1:2, or it could be C2H4, okay? That's 2:4, which is basically the same thing as 1:2. It could be, you could multiply all this, the empirical formula subscripts by 3, and then so you have 3C3H6. That's a 3:6 ratio, which is basically, again, equivalent to 1:2. So C2H4, C3H6, C4H8, all of these are going to have the same empirical formula, CH2. So it's really a matter of determining what the actual subscripts are after you've determined the empirical formula to get to the molecular formula. So to do that, the information, one additional piece of information you need after you determine the empirical formula is you need to find experimentally what the correct molar mass is. So you have to do a separate experiment to determine the molar mass. And that molar mass is just going to be a multiple of the empirical mass, with the empirical mass being just the molar mass that would be associated with the empirical formula. So the empirical mass, you can say, is the smallest possible molar mass. The correct molar mass would just be a multiple of that. So what are the possible molar masses, for example, for a compound whose empirical formula is CH2? Well, carbon. So 1 mole of CH2 would have 1 mole of carbon. 1 mole of carbon, so that's 12.01 grams. And that's 2 moles of H. So that's 2 times 1.008 grams. So that's a total of, that's about 14 point, let me see, 2 times 1.008 plus 12.01, 14.03 grams. So the empirical mass of CH2 is 14.03. So the possible molar masses would be multiples of that. So 14.03 times 1, that's one possibility, times 2, that would be 28.06 grams per mole, which is possibility. Okay, 14.03 times 3, 42.09 grams per mole is a possibility, and so on. Okay, so it's a multiple of 14.03 if the empirical formula happens to be CH2. Let's take a look at this sample question here. Which of the following is least likely to be obtained as the molar mass of a compound with an empirical formula of CH2? Well, what did we say the empirical mass of CH2 was? Empirical mass, we determined that to be 14.03. So the correct molar mass has to be a multiple of that. So like I said, you can go through each possible multiple. You can multiply that by 2, you get 28.06. You multiply that by 3, you get, let's see, 14.03 times 3, that's 42.09. Okay, and so obviously according to this, this is 28.1 is pretty close to 28.06, so that's a possibility. 42.1, that's very close to 42.09, that's a possibility. So 78 must be the correct answer here. The least likely to be obtained is the molar mass of the compound. A quick way to do this, if you don't want to go through all of these possible multiples, is just divide each one of these by the empirical mass. So 78.0 divided by the empirical mass of 14.03, that gives you 5.5556. Okay, that's halfway between two whole numbers, so that's not a multiple. The ratio must be very close to a whole number. Okay, Ideally, it should be equal to a whole number, but of course, when you do experiments, you have random errors. So you should, you know, realistically, you'd get a number that's pretty close to a whole number when you take these ratios, but not exactly equal to a whole number. In fact, if you do 28.1, for example, okay, divided by 14.03, you get 2.003. So that rounded off to 3 significant digits, that's pretty much a whole number. Okay?